This is a short series of presentations to assist paraglider and hang glider pilots who are studying for their BHPA pilot rating exams. This series is on meteorology. In this section, we will look at frontal systems in a little more detail and then go on to talk about clouds. You may recall that on weather charts and forecasts, frontal systems are marked up in the way shown in this graphic. Red lines with half circles being the warm front, while the blue lines with the triangles mark the cold front. The passage of a warm front, warm sector, and then the cold front in the northern hemisphere results in the wind veering at the warm front, stabilizing through the warm sector, and then veering again at the cold front. Veering is a switch clockwise when imagined from above, like in this diagram, or to your right when you stand and face into the wind. The wind is said to be backing when it shifts to your left when you're facing into the wind. When warm fronts are approaching, the first change we may see are the high clouds approaching. These are referred to as cirrus and cirrostratus. As the front gets closer, then lower level clouds such as altostratus begin to develop. Most of the cloud types are sheets or blankets of cloud, hence the name stratus, which is a Latin word meaning to flatten, extend, or cover with a layer. If and when rainfall arrives, it can be an extended period of drizzling rain. When cold fronts are approaching, the cloud types are less sheet-like, with a lot more bumps in them. There can be a huge variety of cloud types, but nimbostratus, altocumulus and cumulonimbus clouds are often formed. Any rain that falls comes in heavy, sudden bursts. The lower graphic illustrates how a cold front is much steeper affair than a warm front as it extends aloft from the surface. This means that the changes come more quickly as the cold front advances. A cold front is both steeper and more fast moving than a warm front, and towards the centre of the depression, the cold front often catches up with and then overlaps the warm front. The frontal area is then known as an occluded front. This area can have a variety of characteristics which are often less marked than either the cold front or the warm frontal systems. That's the basic stuff on frontal systems. Let's look at the clouds that help us understand the weather. Most names for clouds come from Latin and are usually a combination of prefixes and suffixes, such as strato, cumulo, alto, and nimbo or nimbus. It can be helpful to think of cloud naming in terms of the height of the cloud and whether it is a broad sheet, a puffy, bubbly cloud, or a wispy cirrus. The cirrus wisps are usually made of ice crystals. The puffy clouds and sheets of cloud are water droplets. Here are some images of the high clouds occupying an altitude of 20,000 feet or above, and they're usually made of ice crystals. These are the medium-level clouds, usually prefixed by the word alto, which means high in Latin. Bumpy bits are apparent in the altocumulus in the top picture, and compare it with the sheets of cloud in the lower picture, nimbostratus. The base for these alto clouds is usually somewhere between 6,500 and 20,000 feet. You can get sheet-like stratus-type clouds in the lower levels, but generally at heights below 6,500 feet, the height below which we usually fly, we have bumpy-type cumulus clouds. It is particularly important to be aware of cumulonimbus clouds. These clouds build more energy as the air condenses and can rise extremely high with immense power. They have a dark base and often expand with height. The ones with flat tops can acquire an anvil shape which can be quite distinctive. As a free flyer, predictions of cumulonimbus need to be taken extremely seriously, and clouds that start to build suddenly should be treated with great respect. Here are one or two more images of common cloud types. Cirrus are the high wispy clouds made of ice crystals. Altostratus are the mid-level sheet-like clouds. And our friend cumulus clouds signify the tops of rising air in strong convective conditions. These are the conditions that free flyers depend on when flying cross-country. Fog is where the moisture in the air condenses at ground level. It occurs when the air is still and the earth has given up its heat and forms a very cold surface. Air condenses in a very similar way in which it may condense against cold windows on cold nights. Advection fog may occur close to the coast. Sea air is inevitably more moist than air over a landmass, and it can condense when it's drawn over the land near to the coast. Land gives up its heat much more quickly than collections of water in seas and lakes. Orographic cloud is a specific type of cloud that is the result of air being forced upward by the topography of a mountainous area. As it rises, the air cools to the point at which the water within the air condenses. This temperature is known as the dew point. Lenticular clouds are formed in conditions described as wave. We will be looking at how wave conditions develop in a later section of this series. This graphic is taken from Graham Taylor's pilot examination notes, and it's a summary of many of the common cloud types and names. So this section has covered frontal systems and clouds. In the next section, we'll take a look at convection.